Hello everyone and welcome to FiST Chat, the vodcast that features discussions on the topics of film, science and technology. My name is Ben Warner and I'm joined once again by my good friend and colleague Steve Kern as we discuss some very interesting science news today. Hey Steve.
Absolutely. Hello, everyone out there in FiST Chat land. Wow, isn't it fantastic to be alive in this universe?
Oh, absolutely. And something that hopefully we'll get to discuss a bit later is should be an interesting 50 or so years the next the next couple of decades because it's almost like you ain't seen nothing yet kind of thing.
Absolutely. For everybody that is a FiST Chat follower who loves science and loves those big questions, we're actually going to start answering some of them, and of course that's only going to make us ask more questions.
and we can ask them and talk about them right here, so we'll have enough material to last us for a while, won't we?
Absolutely. FiST Chat's going on for another century, folks.
Absolutely. So we're going to talk about a couple of things today, but we'll start off with the Higgs Boson particle, which was so far has been, if I'm correct, you can correct me if I'm wrong here, it's one of the only particles that hasn't been observed in particle physics as yet?
Absolutely. Look, to be honest, there's only a few people that are really experts on this in the world, and I'm not going to pretend to be one. But very quickly, everyone's heard of Einstein's theory of relativity. Okay, that's part of what physicists refer to as the standard model.
Yeah.
Okay, and that's how everything interacts on a subatomic scale, effectively. Okay, so you've got protons, electrons, neutrons. Then you've got their smaller subparticles as well. We're not even going to go there in this. However, through this, and this is all theorized. This was all theorized probably from back at the start of the 20th century. And what's happened is, ever since then, physicists have done experiments based on these equations and proven that these particles that the standard theory says exists. However, the overall theory never quite added up. And in 1964, Peter Higgs penciled in some equations, and basically he suggested that the reason that we all have mass, that is, we weigh something, is because of something known as the Higgs field, which extends all the way through space. Okay? And it's kind of like us being in a swimming pool and wading through it. Imagine if we couldn't see the water. It's that sort of resistance, and that's what gives us mass. Yep. Now, he hypothesized this Higgs field existed. It fits very nicely into the standard theory. Scientists built the Large Hadron Collider, the 27-kilometre ring underneath the mountains in France and Switzerland. They've been smashing protons together in that tunnel and looking for the Higgs boson, which is a particle which suggests that the Higgs field exists. How much more complicated can you get than that? I hope everyone in FiST Chat land is still listening. Basically, it means that this Higgs field exists, and that's why all of us have mass. And what is important about that is if we didn't have mass, stars wouldn't have mass. The universe as we know it wouldn't exist. We wouldn't exist. We wouldn't be here on FiST Chat. We wouldn't even be thinking about this, Ben. It's big news.
No, absolutely. And that's why it's becoming an interesting news story at the moment, because there's going to be an upcoming announcement of sorts from the guys at CERN, the experts at CERN, with some of the stuff that they've been experimenting with. And as we were just discussing before we got on, it's not necessarily that they'll say, "Oh, we found it" or whatever, but maybe they've found something very promising that could lead eventually to a discovery in the not too distant future.
Well, apart from the fact it took them 20 years to build this gigantic machine to have a hope of finding the Higgs boson, they're very hard to produce because it takes a hell of a lot of electrical energy to in a very, very small space to create them. And what they will have done is they will be doing this literally thousands of times and building statistical bases that show particles. Now, the thing is, the Higgs boson could look like a whole number of other particles that also occur in decay. I guess is a simple way of putting it. They have to do this experiment thousands and thousands and thousands of times to ascertain whether or not they have found the actual Higgs boson. And when what they're doing now is they're approaching a statistical size or sum where they're confident they may have found it. It'll take probably another 6 months before they can verify that.
Well, they would have had to have been fairly confident that they would have found this thing anyway. As I was reading in many of the articles about this, that they were jokingly saying, well, we didn't build the LHC just so we could maybe find some stuff. They were hoping to actually find stuff that they felt does exist. So otherwise it's an expensive donut.
Exactly. It'd make a great sideshow ride, though. Look, this is huge. This will open new doors to us in our understanding of the universe. Not just the one in which we live, not just the tiny pieces of the universe that make us up, but also other worlds in the universe, Ben.
Absolutely. That's a nice little segue into our next little story today. I guess talking about mass, universe, planets, there was a Earth-like planet found, the Kepler 22b, that's roughly, I think they said it was around twice the size of the Earth. They had actually found it 2 years ago, but it's been the research that's been done just recently that has pointed to the fact that it's very similar to Earth. It's in that Goldilocks zone where, just like we are, we're in that nice little patch that gives us life. And
not too hot, not too cold, just right.
Absolutely. So there could be oceans, continents, and then by extension, potentially life, which obviously is where this story is getting so much traction because, it is very similar, apart from the fact that it's twice the size. It seems to orbit sort of roughly in the same sort of amount of days, a little less, but about the same amount of days as Earth does. So is there a lot to get excited about here, or are the scientists jumping the gun maybe? Because it is very far away. How do they know that any of this stuff is actually out there?
Look, this is simply amazing. And we spoke about the Large Hadron Collider, which is what we've just been talking about with the Higgs boson, and the Square Kilometre Array of telescopes back in FiST Chat episode 16. We're talking about them together again in this episode. This is huge. What we're doing now was unthinkable 10 years ago with what we're seeing in outer space. This planet is 600 million light years away, 600 light years.
So it was fairly far away, I would have thought.
It's a long way away, but the fact of the matter is that it's close in cosmological terms. This is incredible. SETI, the search for extraterrestrial light, has just been waving the telescopes madly in the sky. We're now on the verge of having brand new, ultra-powerful telescopes, and we can also pick where the planets that might have organic life are, Ben.
Yeah.
Our chance now of actually contacting life maybe slightly like us, provided they have radio telescopes as well, have increased dramatically. This is big, Ben.
And that's why I was saying at the top of the episode, this is going to be an exciting time this next 50 to 100 years. As you just said, even 10 years ago, the technology wasn't necessarily there to do this type of, at least this type of discovery. But then if you look forward, what are they going to have in 10 years' time, 15 years' time, 20 years' time to look at all of these things? And what is fascinating to me about this is that it's pseudo space travel and exploration. We're not actually leaving Earth at all because practically we can't do it. Instead of doing the whole Star Trek thing and zipping around in spaceships, we're essentially able to explore so much of the universe around us just by looking at it, just with more powerful instruments.
Well, that's right. I mean, look, I don't even want to start speculating, but who knows? Discovering the Higgs field and understanding it may mean that we can make that journey to these planets much more quickly, just like Star Trek. that'll be well in advance of our lifetime and our children's 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 children, but it's a possibility. And, you know, with the telescopes now getting more and more powerful, this is how we've picked up the planets. I mean, astronomers have known for years that there are other planets out there, but they weren't able to see them until only a few years ago. Now they can see them. I mean, that's incredible. The size over these distances, they can see them. The next great technological leap in telescope technology through the SKA will be they'll actually be able to have biosensors. So here on Earth, you've got trees which are green because they photosynthesize, okay? Theoretically, you could build a telescope that could search for chlorophyll or for that green reflection. You have oceans, you have clouds. You could actually look for particles in the atmosphere that suggest life. We will actually be able to, probably within, as you say, the next 50 years, detect life. We may not be able to talk to it, but we'll know it's there. And that will change everything for humans.
Oh, yeah, absolutely, because it just automatically, by default, just changes our perspective on where we sit in the universe in the grand scheme of things. If at the moment we can't categorically say that, you know, either we are the only ones or we're not the only ones here. So if it turns out there's more than just us, or as what was it in Contact, that line? It'd just be an awful waste of space if there wasn't anything else out there.
Sounds like you're really hoping to meet E.T.
Oh, well, as long as he's friendly or like Paul or something like that, then I'll be fine. But no, it's very exciting stuff. And the other thing, though, just the one final spin on it, of course, is that when we're looking at all of these things, all these planets and that, the other thing to remember too is that we're actually looking at them in the past.
Yeah.
So that's sort of something a bit hard to get your head around when you're looking at something that, say, for example, if I'm not sure what the distance was, but if it was, you know, say 1,000 light years away, then we're actually seeing what it was like 1,000 years ago.
Yeah, yeah. So, well, we look at a lot of stars that are a lot older than that. You know, 100,000 light years, you know, across the Milky Way.
Yeah.
That's, you know, that's big. And then you go to other galaxies. So it's huge. You know, we can't begin to comprehend what this means.
Absolutely.
You know,
but we take those baby steps though, and finding particles like the Higgs boson's a good start, and it's just one small incremental step at a time.
Yeah, look, I'm absolutely delighted that these discoveries have been made. They're really exciting, I think, you know, and they won't change people's everyday lives yet. But as we understand more and we understand our place in the universe, then I think the truth is that it'll enrich all our lives eventually.
Absolutely. Very good. Well, I think that might be a good place to finish up. A nice thought there. So, yeah, thanks again, Steve, for the chat.
Anytime.
Always interesting to talk about science because I have a very strong interest in science fiction, of course, and it seems like science as a way of catching up to all those things that we see in movies and TV eventually.
That's right. I mean, you know, Hollywood are the prophets.
Absolutely. Cool. Okay, so that's another episode in the can, so to speak. So we'll be back again next week. So until then, have a good week.